Okay. Put a finger down if you thought this talk would not happen and you just downed a pint and now you have to give it anyway. Let's see how it goes. So, welcome everybody. I'm super excited to be here with you today for quite a few reasons actually. It's the first time I'm speaking in NDC London, and it is the city I've spent the last 10 years of my life. So, super excited to be on this and talk to you about controllers and minimal APIs. So, quick intro. Hey, my name is Chapsas. This slide is a bit outdated. I'm not working for Checkout anymore. However, you should check that company out. Great company, great employer. You should give it a chance if you're thinking into moving into fintech. A bunch of other stuff. You probably know me from my YouTube channel, and I also have some courses on my own website nickchapsas.com, if you want to give that a go for topics like minimal APIs as well. So let's dive straight into the topic, which is minimal APIs. Now, how many of you know what minimal APIs are? Show of hands. Okay. And how many of you think it's something you will never put in anywhere near production? Okay, so the goal is to not think that way by the end of this talk. Now, in case you didn't know, minimal APIs are by far the most loved feature of the .NET 6 release. Everybody just loves them. It is amazing to see people come together and embrace the simplicity of using minimal APIs and really thinking that adopting something that other languages have been doing for years and moving away from controllers is something that we really can do in this community. This joke is going for way too long. In reality, people are a bit mixed about them, to say the least. Some say that they're junk. Okay, let's see if we can change that opinion. So, what are minimal APIs? Now, this is the point where I could be very sophisticated and have a fancy quote and explain what they are. But you do know what they say. One picture is worth 1,000 lines of code. So here's a picture with 4 lines of code. So this is fundamentally what minimal APIs are about. It's this idea that we can strip down everything about building APIs in .NET, and this file is a valid API in C#. Now, that's a bit of a lie. The only other file you need for this to be a valid API is actually a CS_proj file, which specifies this as a web project. But once you have that, there are no using statements, there are no namespaces, no classes, no public, static, void, main, string, array, args, and so on and so forth. You just have that. Now, some people are a bit intimidated by this simplicity, and they think that this is immature, this is not something they ever want to attach. Where are my controllers? Well, let's investigate that claim a little bit. But I want to emphasize something. This is not something new. You might be thinking, wait a damn minute. That thing over there, that looks a whole lot like that thing. Now, blink it, you miss it. The top thing is minimal APIs in C# and .NET. The bottom one is Express.js from the Node world. So this idea of going from point 0 to point I have an API very, very easily and very, very quickly is not novel. It's how JS has been building API for years, and it's not really limited in the JS world. For example, Python with Fast API, this idea that all you need is that Fast API app, and then you specify the endpoint and you have the hello NDC. Very, very simple, very, very easy to get started. Let's go ahead. Go, lovely language. Many people love it, many people use it. Same thing. You have Gen, a framework which allows you to create an app and then have that get or post or put or delete and just quickly return a string or anything that you want and build an API on that. Let's go ahead. Anyone remember Nancy over here, Nancy effects? Do you remember this being a thing? So this used to be a thing in C#. All you needed to do is have this get, and then you point to a delegate that returns a string, and that would return that text. Now, Node kind of faded away for other reasons, which we are going to investigate as I go on, and it was reincarnated in the form of a project called Carter, but I don't think you should really use that as opposed to minimal APIs at this point, but we're going to talk about that as well as I go on. And also I'll go on with Sinatra, which is what Nancy affects, Nancy Sinatra, that's the whole name thing. You just have get, you have the endpoint, and you have the hello world, and that is it. So clearly, for years, this is very, very old actually, the need to get from nothing to something that returns some data on the web has been around. And if you actually look deep down inside other languages, controllers and that whole concept of building APIs with them isn't really much of a thing unless they have MVC into a framework, for example, Ruby on Rails. But you might be wondering, how is that even possible? How can we just have these 4 lines of code with no using statements, no namespaces, no classes, no nothing, and that is an API? Well, I made a bit of an animation to show you how that is possible. All those features from C# 9, 10, and .NET 6 APIs are coming together. You can tell about how proud I am about this because it has a watermark with my name on it, because I don't want people to steal it. It took me a long time to make. But this is how minimal APIs are coming together. Let's see it again. It took me 3 hours to make. So these features are just coming together to give us minimal APIs. I'm going to skip this early. No, let's just see it. I don't know how big the Power Rangers were in here, but back home in Greece, they were a bit of a deal. So this is how this is possible. And we're going to see every single feature to see how we got here. So top-level statements are actually a C# 9 feature, which I kind of hated when it came out. But in C# 8, you have to have that using statement, that namespace, which is optional, but you had it anyway, then the program class, then the public static void main string array args, as if we're insane and we're writing Java for some reason. And then we have the actual meat of the application, which is the console.writeLine and then hello world. So with top-level statements, we no longer need that. All we have to do is just say using system and then console.writeline.hello world. And yes, I could cheat if I did really want to and just merge system with the console. But then I couldn't have this amazing segue into the next feature, which is implicit using statements. So that problem, we no longer have that because the C# team said, well, there's actually around 7 namespaces that you're going to import on every single file most of the time anyway. So why don't we just imply that they exist already, and then as long as you say, yeah, use implicit using statements in that CS proj file, then you can just say that. You don't need system. Which is another awesome segue to the next feature, global using statements. Because now what I can do is I can have a file, a CS file, that has global using and the statement, hence the name, and then that will be automatically imported in every single file, which is coincidentally exactly what this flag will do on the CS proj, the enable flag, because it will actually kick in a source generator behind the scenes that will drop that exact file. So implicit using statements are a bit of a mixture of global using statements and source generators. Also, inferred lambda types. Until C# 9, the compiler here has all the information it needs to determine that this is a function that accepts a string and returns a string. But if you try to do var or try to maybe inline this lambda somewhere, the compiler will be like, I really don't know what this thing is supposed to be. Can you please specify it? And you either had to cast it or create a new func of something. So it was a bit frustrating, and there wasn't really need for them to make it be inferred. But now in C# 10, we do have that because the .NET team kind of needed this for minimal APIs to make sense. If you actually saw early demos of minimal APIs, the people who were demoing them, especially Scott Hunter, I think, he had to cast it, and it did look a bit ugly. So it's great that we have this here now. Then the last feature that we got is attributes on lambdas. So previously, this would not compile. You could not have the attribute, the obsolete attribute, on the lambda itself. Now you can, and this makes sense because if you think of minimal APIs, if you have seen them before, and we're going to see them in a second now, you can actually specify things like allow anonymous or authorize attributes on the lambda itself. But enough with that. What I want to do is I want to go into a demo just to make sure everyone is on the same page. So let's go and do this. I don't know why I'm doing a live demo. I probably hate myself, but let's give it a go and hope it doesn't fail. So what I'm going to do is I'm just going to create a minimal API. And the first thing I need to do is just say minimal API.demo and create a console app. I'm explicitly not making an ASP.NET Core application or a web project, just to show you how from nothing you can actually create a minimal API. So project is created. Can I have a thumbs up if you can see this? Or if not, I can, all good? Okay. If at any point you can't, please shout and I will change it. So I'm going to go ahead over here and I'm just going to go to the CS proj of this project. And I'm going to change the SDK to have a .web. And that's all you need. A console app now magically is turned into a web API. Now, the web API has two fundamental components. The web application builder, which is where you do all the configuration for your API, and then the web application itself, which is where you configure all the middleware. So let's go ahead and see that. I'm going to create the builder first. So I'm going to say builder equals web application dot create builder, and I can actually access the arguments of the program.cs as if they were there. So I'm going to pass them down in case someone wants to pass down some settings. So that's my first construct. Then I have the application itself. So it's a materialization of the web application builder. So .build goes here, and then app.run. And that's it. I have my API. At this point, it doesn't have any endpoints, obviously, but I can add them in here. And effectively, all this really is, because you might be thinking, well, where's the startup.cs? Where is my configuration? Where's everything? Well, you can treat this area over here as the configure method of the startup.cs. And you can treat this area over here as the configure services of your startup.cs. So anything in here you configure. Once you materialize your application, you cannot actually retroactively update anything. So if I was to access services and add a service once my app has been created, well, that is no longer applicable. It won't change because I have my app already here. So let's go ahead and create our first endpoint. And all I need to do is say app.mapGet, and I'm going to have your typical hello world. So that's all I need, hello NDC. And I got that. Now, in order for me to run this without having to stop and start on my IDE, I'm actually going to go to the terminal and do one of these. So I'm going to say minimal API.demo. Here we go. And I'm going to say .NET watch run, but I'm going to choose not to use the hot reload feature. See, that's my choice. I don't use it because I want to. Imagine if someone thought removing this feature is a good idea. Anyway, that would never happen. Anyway, so this will now start. Let's give it a second. And now every time I update this file, the application would restart. So I have that, and the way to call this without having to go to Postman or another application is I have a bunch of predetermined requests in this HTTP file, and Rider, my ID, allows me to call them. So I can call that endpoint, and of course, it didn't show me what the response is, but you can see it here, hello NDC, I get the response back. So if I go back, I can do other things as well. I can say map get, and I can say, for example, hello object, and I can just create a brand new anonymous object here. It doesn't have to be a real one. All I can say is message equals, and then have my text hello NDC. Very easily. And I can also actually mix a couple of other things as well. I'm going to create a record over here called user, with a full name. And I'm also going to use a class called results. So I can say user, and then return from the results class, which effectively has a bunch of predetermined ways to return a request. So text, stream, unauthorized, bad request, sign in, sign out, all the typical things you would also have in the MVC world. All of them are here. So I'm going to go ahead and say just OK and create a new user. And of course, it will be me. OK, so with all those done, I'm just going to pretend like I'm pausing so the hot reload restarts. Hello NDC works. You can see serialization takes care of the case as well. It's not capital M. You can customize all that. And also, if I want to get the user, everything just automatically works out of the box. Now, I can actually also access a bunch of special parameters here, because until now, everything is parameterless. We don't really use anything from the request. We just return something. So let's go ahead and do that. I'm going to go ahead and say special over here, and I'm going to access a few special parameters. And I'm just going to return an anonymous object. So the first thing I want to access is actually the HTTP context. So I can say context, and this now will be automatically injected And it gives me access to things like the connection, the features, the items, the request, the response, everything. Now, for my taste, that is a bit of a quite wide object, and I wouldn't really use that in any case, really. So what I want to do instead is access the HTTP request directly if I want something from the request. And I can also break it down and access the HTTP response directly, right? So I can do a few things with this. First, I can actually write to the response with a JSON object, which means I no longer need this new return. I can take control and return that, and we're going to return a few things from the request, but it also means that because this is an async method, I can change this delegate to be async as well. Let's make this like that, and let's delete this actually so you can see what's going on. And I can say await over here. So now I can grab something from the request, for example, request.query, and that's the query collection. And if I save and I give it some time to recycle and go back and run this special request, then you can see that it's grabbing that age parameter and it's printing it over here. So very simple. There's other special parameters you can access as well. For example, you can get access to the cancellation token if for some reason you want to pass it down. In fact, rider my ID is telling me, hey, I can do something with this cancellation token. Let me just pass it down for you. So here we go. And then the last thing I want to show is how you can do a more extravagant request, which brings in a lot of the stuff that I just showed you. For example, what if you want parameters like a query string parameter, or a route parameter, or the body of a request? So many things to choose, or even a header. So let's go ahead and do that. I'm going to say map get, in fact, map post again. And yes, there is a map method for a bunch of different things. Map delete, map get, map post, map put. There is no patch. I don't know if they're going to add it. It's not like I'm using patch anyway, so it's fine for me. Extra is the endpoint I'm creating. And let's say I want to pass down a parameter from the route. So let's say I want to pass down the year parameter from the route. It's the exact same thing you would do in controllers. You specify it like that, and then you can map it to a parameter over here. Let's say you want to have a query string parameter called age. Well, you don't really need to do anything for that. It just magically works because it implies that if it's not specified here, then it's probably coming from the query string. What I'm going to do is I'm just going to print them so you can see them when I call this. So I'm going to say age. Now, let's say I want something from the header, because if you see over here when I'm going to call this, I actually have an accept header. So what I can say is string accept, but here's a bit of a problem. This doesn't know how to map the accept header. It will assume that accept is a query string parameter because it's more of a common thing to do, so the default behavior is this. So instead I'm going to say from header and be explicit about it. And last but not least, because as you saw on this request, I also have a full name, I'm going to pass down from the body a user. And as if this wasn't chaotic enough, let me just pass this down. I'm going to go ahead and copy from this file this datetime provider class, which allows me to have mockable date in my application. So for that to be able to be injected, I need to go up here and register it. So builder.services.add singleton I datetime provider, and then datetime provider. Cool, cool, cool. Okay, so what I can do now is I can also inject datetime provider. Now, that's quite a lot of implicit statements, but if I go back here and I call that API request, then it all magically gets mapped. Well, with code. So you can also be explicit if you want to. For example, if for some reason the age parameter, you want it to have a different name in the header or the query, you can also say, for example, name equals A, and then what you can do is go back here, age is A, and so on and so forth. Those are the basic constructs, and you still have it mapped over here. So I hope we are now all on the same page on what this thing is, because we kind of need to put that in context because I'm assuming all of you know what MVC is and what a controller is and what Web API is. And this talk will be a bit critical about those constructs now. So with all that said, and let me just cancel this because if I forget it, I might fail the next demo. So let's move on and let's address something. There are a few unsupported features in minimal APIs. It's not all happy days. If it was, everybody would be using them, hopefully. The first thing is there is no support for filters. So things like the async action filters, the result filters, the exception filters, those things are not supported. This support is actually being added in .NET 7. However, they're a bit of a different thing. I mean, it's still the same concept, but you cannot reuse your filters that you have on MVC in minimal API. So you're going to have to remap them. But it is coming. Then there is no built-in support for validation. So as you saw, it did have model binding, but a model validator would not work. For example, if I tried to have a required header in my model, even if the value wasn't there, this thing would not throw an exception. So you'd have to write your own validators, which for me is fine because I'm using Fluent Validator and I'm wiring it up in MVC anyway. So there's not much of a problem for me, but I can totally see how this can be off-putting for some people. There is also no support, like I showed you, for JSON patch. Again, something I never really had to use, but I can totally see how some people would benefit of having that. And likewise for OData. OData is not supported, and that's all I'm going to say about that. And also, last but not least, there is no built-in support for API versioning. Now, this is not the concept of API versioning. You can have API versioning if you want. You can just make a folder, call it V1, put it in the namespace, yada, yada, yada. But you cannot use the API versioning MVC package, which has all of that automated for you, and you can have it in a header, the media, accept media, I think header, or a query string parameter, or part of the route that is not supported. I think that's because it's based on filters for some stuff, and we didn't have filters, so someone might remake that in the future, but as far as I know, it is not supported currently. But I want to address another problem, which is actually caused by me showing you that program.cs file, and it's called the program.cs hell. So the other day, which when I wrote this was the other day, this is actually 7 months ago, is this tweet by someone who said that, hey, I chose to build a minimal API because .NET 6 is out and minimal API is the new thing. So I'm going to use that. And I ended up with 6 methods, the map-get methods in that program.cs, 6 classes. They hate themselves. They feel that this is wrong. Why are they doing this? Web API just feels better. Who thinks that minimal API, actually, who thinks that Web API is better than minimal API? Can I see a show of hands? Okay. So what's the last time, anyone, not just the people who disagreed, what's the last time that you created an API, let's say it was a customer's API, an API that manages customers in your domain, and you created the customer's controller, and then in that controller class, you also slapped your customer's mapper, customer's validator, customer's service, customer's repository, any EF core stuff, maybe mediator was in there as well. You didn't, because you're software engineers, and you structure your code. Minimal APIs are not different. Minimal APIs are not about having everything in a single file. They're about stripping down everything to its basics so you can choose your own destiny and build the structure that you want. So let's recap. What minimal APIs are not. They're not one file APIs. I know it's very convenient for demos, for people like me, to show you everything in one file, because I don't have to jump around in 50 different files and explain what this controller and this service and this repository and how everything is injected. You just have everything in that single file, and it's very convenient. They're also not just for demos. But like I just said, they're very convenient for demos because everything is in that single file. I have this choice. Do you think that if that was the choice in the past, I would have a program.cs, a startup.cs, a controller, a service, a repository, and so on and so forth? No, because that can be confusing for demos. They're also not just for beginners. Some people think it is just for beginners, but as we're going to see later in this talk, I really don't think that this is the case. They're great for beginners because it delivers to that promise of from nothing to an API that returns something very, very easily, the same promise that Sinatra, Nancy, and those other APIs had, but it's not just for them. In fact, the concept of a minimal API can be tied very nicely into another minimalistic concept that many of you, I'm sure, are using. And last but not least, they're not going to kill controllers. I know many people think that this is the case and that Microsoft will actually make controllers obsolete in favor of minimal APIs. A lot of that discussion has actually started because someone who is working on minimal APIs by Microsoft has replied in a comment that they expect 70 to 80% of all the future use cases to be done with minimal APIs. I think it's a bit of an optimistic metric. I think many of them will be eventually adopted, but 70 to 80, I don't think so. And I also did crunch the numbers after extensive research, and I did find out that if Microsoft were to choose to kill controllers, they would break approximately 100% of all the software out there running APIs in C# and .NET. It's not going to happen. So I want to take a minute now, and before I go to this mini rant, I want to take a second and just address the elephant in the room. It is a bit of a rant, this one. I won't bore you too much. It's only like 50 bullet points, but we'll get there. Controllers for building APIs are weird. There, I said it. How many of you think that they're not weird and they're great for building APIs? Show of hands. OK. So they're weird for a few reasons. Now, why do you think we're using controllers when we're building APIs in .NET? Do you think the 10 smartest people in Microsoft sat down and they said, well, it does look like that architecturally and structurally and everythingly, it makes sense to have controllers as the way to build APIs in .NET. That is not the case. The only reason why we have them is because Ruby on Rails was a thing, and then Microsoft thought, well, we kind of need an MVC framework as well, and they built MVC, and controllers do endpoint, routing, model binding, and validation. So they were like, can we just rebrand this to another thing, call it Web API and call it a day, and just give it to people and say, this amazing new way to build APIs is here, just use it. That's the only reason why they're called controllers. There could be modules, there could be endpoints, there could be anything, as far as I care. I don't care. But we have to acknowledge the fact that this is not the starting point. Controllers are just one of the end goals. And it's one of the many end goals. Usually you start with minimal APIs or the equivalent in a language and you get there. But here's the thing, because we're using controllers, which is the C on MVC. But what's the last time you used a view when you're using a controller? Because the whole point of having a controller is it's part of MVC, but you don't use views. So why are we using MVC constructs to build APIs? And likewise, M, the models in MVC, is more about business logic. It isn't really about DTOs and API contracts. And in fact, when you're building APIs, a different thing is coming in, a different thing is going out, usually. So what's the point of using, we're just left with C. Why are we using an MVC thing? And we just normalize that, yeah, this is fine, this is acceptable. It is not. But the reason why it is that it was actually the only viable way to build APIs. And yeah, someone might say, hey, Nick, non-CFX was a thing. I was using it. It was great. Well, the truth is, for it to be dead, not enough people were actually using it. And also, people are just prone to not adopting something that it isn't supported officially by Microsoft. Minimal APIs are, and now controllers are as well. And we're going to see how that goes as the time moves on. They also have these methods, these actions, that never really call each other. You would never have one action call another action. And if you're doing that, don't. And the reason why they exist in that controller is because it made sense, because in the MVC world, the view would actually refer to both the controller and the action by name, or sometimes just the action by name. So you'd have IntelliSense. It would make sense that everything would be grouped logically, because it isn't the black box that is calling those endpoints. It is your view. So why are we using that again? And then they kind of low-key violate sync responsibility, because you might think it's not, because you say, hey, Nick, my domain is the customer. I have customer controller, and everything is in there. My create, my update, my delete, everything is there. No violation. Well, I would argue that it also kind of violates open-closed on top of that, because every time you want to go ahead and add an endpoint, you have to go and change that existing class that has nothing to do with you adding an endpoint or deleting one. In my opinion, they should be separated in separate endpoints. So let me just quick intermission because I'm a bit tired. Okay. So they also have these services injected into them, into the actions, or the controller actually, but they're not used sometimes by all the actions. So you would allocate an object in that controller being instantiated, and then you would waste all that memory for allocating that object and have to garbage collect it as well, even though it's not used by all actions. So why are we doing that? And someone might say, hey, Nick, I'm using the from services attribute, and I'm only injecting it in the method itself. If you're doing that, great. I haven't really seen it. All I see is the lazy way of just go with a constructor and just hope we don't care about memory, basically. And also, they never share state between actions. So why are they sharing real estate? Because they're all scoped anyway, and you wouldn't call one another. So what's the whole point of having them together? I don't get it. And when you have private methods, they usually are only called by a single action. They wouldn't be called by multiple actions most of the time. And middleware and filters that you have, because it is coming from NDC, a lot of that was actually just left in there from NDC. And for example, validation is called everywhere. So you have them be comparatively slower than minimal APIs as well, because you have to invoke and allocate those objects. And even if it's just an if check to walk out of the flow, minimal APIs have a 10 to 15 realistically % performance boost over controllers. I won't dive too much into the performance point, because performance is contextual and it doesn't mean the same thing for everyone. Like if you have a database that takes a second to respond, minimal APIs won't just magically make your API fast. They can also grow quite a lot, and we have this questionable term called fat controllers, and we just do everything we can to just remove stuff from those controllers, because someone is like so proud when they have, oh, like my controller is just 3 lines of code. That's how simple it needs to be. Well, how about you remove that controller altogether if it needs to be so simple? You don't need it. Move the mapping outside, send the thing to mediator, which is what you're going to do anyway, and just move on with your life. So this is what it can look like for a new developer working in as a junior developer or as a seasoned developer from a simpler ecosystem like Node, like Python, like Go. So they just want to build an API, but then they have all those things dropped on them. And it can certainly be overwhelming. And sometimes we forget that some people just want to build APIs. They don't want to build, just want to build products. They don't necessarily want to build your clean architecture with 3 layers and onion and hexagonal and all those fancy words that you probably don't need. So what is this talk about really? Well, like with everything in this life, it's all about Lego. It's always about Lego. I promise it will make sense. What do you see here? Just silently in your mind, think about what you see here. If you say you see a half-finished Lego set of Hogwarts, you're wrong. I mean, that's the right answer, but that's not where I'm getting. So what you have here is the foundations of some castle. I can see some windows. I can see a door. There is some structure to this thing. It's not finished, but there's certainly some structure. I can also see a window this way, and there's no back wall. Now, what's great about this structure is that if I give it to my nephew who's 5, and I say complete it, just because of how much foundation there is there and how much work has been done by default, they will probably finish with something like this. I mean, they're 5, so maybe it looks a bit worse, but something around that. But also, me, who's not an architect and I don't know how to build castles, if I take that, and I've done my fair bit of Lego, but I'm not a castle expert, I can still create a fairly good-looking castle, something like this. Now, let's take a step back. I go to my nephew again. And instead of giving them an unfinished castle, I give them ground, and I give them a bucket with infinite amount of Lego of any size, any color, any length. And I say, build a castle? Well, they're going to probably build something like this. Now, does it look like a castle? Nah. If I ask him, he'll be like, yeah, it's certainly a castle. I can see a door, I can see the ground, there's a torch somewhere there. It is amazing. Now, I wouldn't say it looks like a castle. I think it looks bad. I wouldn't tell it to him because he would cry. But at least he's engaged and he got into using Lego. And to his eyes, he did build a castle. He can play with a castle, and you know what? Next time he builds another castle, maybe it will be less shitty. But if I go to my uncle, who studied architecture, and I gave the same tools, then most likely he would make a masterpiece. Do you get it? That's what minimal APIs are all about. This is what controllers look like to me. There's a lot of opinions about something in there. There's a lot of stuff on how it should be built. Your model validator, your model state, how you can extend that specific controller base, how you need an API controller attribute, all of those details on how you should structure your project and what it should do by default are there. And what's great about that is because a junior developer most likely will build an API that looks like this, because once you have that controller set up, it's very unlikely you're going to fundamentally mess it up. But someone who's mid or senior as well can take the exact same thing and build maybe a bit of a better one of a castle, but again, a nice looking castle. But here's the thing with minimal APIs. If I break down everything to the bare minimum, and I go ahead and I give them to a junior developer or someone who has never built an API before, but all they care about is to build a product, and the product happens to need an API. And I say, look how simple it is to build an API. You have all of these Lego bricks and a ground. Go ahead, go crazy. They will be happy because they did build an API that works for them. Is it a well-architected API? No. Does it matter if it works for them? No, because next time they're going to build it, it will be pretty good. But what happens with someone who's a true senior staff, principal, whatever word they invented today for calling very senior engineers, if I give that to one of those people, one of those architects, then they most certainly will build a masterpiece, and a masterpiece that works for them. And that's exactly what minimal APIs are about. It is about you. It is about choice. So let's go back to the first question. What are minimal APIs? Well, to me, minimal APIs are an unopinionated way to build high-performance APIs in .NET with the minimal amount of implicitly added features and the maximal amount of flexibility to explicitly opt in the features and the structure that you need. It's about you. It's about choice. So let's see what is possible when you can have that sort of power in your hands. Let's go back to the first demo, actually the second demo. And I'm going to go ahead and I have this API over here, which I'm not going to show you what's in there, but I'm just going to run it. And all you need to know is that this API is a customer's API microservice, and it is a REST API. So I'm just going to make this smaller. I'm going to expand this, and I'm going to show you the endpoints. So you have your classic REST get all resources in a given API thing, so no customers in my system. This is using a real database, by the way, with the right responses and headers and everything. Then I can go ahead if I want and create a user. So let me just mess up my email a bit. So that is definitely not my email. But if I am to create a user, and let me just find it here, you can see that a.com is not a valid email address. So I have full validation here. I can also, for example, use the date in the future and try to call that. And it says your date of birth cannot be in the future. So full model validation and domain level validation for my thing. That's definitely not when I was born. That will be ancient. And I'm going to go ahead and create me. And I can go ahead and get me as well from that get endpoint. So I'm back. I can also mess that endpoint a bit and point to something that doesn't exist, and I get a 402 exactly as you would do in a REST API. If you say that this should return 204, you are wrong. And I can go ahead and update this as well. So my username will be different. So I have exactly what you would need for REST API. And then just to wrap this up, I'm just going to call delete, and I'm gone. 204, no content. The user was deleted. And if I do it again, 404, resource not found. Now, let's take a look at something else. I'm going to go to Swagger. I'm going to refresh this page. And this is the Swagger. Please move, OK. And this is Swagger from my API. Now I have to look at this because it wasn't updating. And you can see my endpoints here, documented, create a new customer in the system. I have my request body. I have the success code, so 201, 400, get, delete, get again, and put everything is here with exactly what you'd expect from an API that respects itself. Now, how is that done with minimal API technology? Because all of that you just saw is built with minimal APIs. Now, here's the API. Remember, minimal APIs are not about the minimal amount of code. It is about the minimal amount of setup code and stripping down everything to its bare minimum. So for me, an endpoint looks something like this. All I need to have is a class, an endpoint class, which for this to be registered, all I need to do is create it, and then I extend the endpoint class. I slap an HTTP post here and allow anonymous, and then I have my request and my response. Very explicit, very descriptive. I can inject any service I want in here, and I only have a single handle method because that thing is supposed to do one thing and one thing only, to handle this create customer request. And then I'm sending that to a service because I don't need mediator in this case, and then I'm just returning it back as a created at with the right location header and all that. And if I wanted to add an extra endpoint in my API, I just create a new class extending the same things. Now, I also have validation for those things. And again, those are implicitly registered. All I needed to do is extend the abstract validator, which if you are familiar with Fluent validation, this definitely rings a bell, and then point to that request over there. So that just magically works with code. And then last but not least, the summaries. Those are what is used for the documentation in Swagger. So if I went ahead and I deleted that, then that documentation would be gone. And again, I didn't have to explicitly register any of that. Now, how this all hangs together, and you can find this code, by the way, on my GitHub under Clean Minimal API, which is ironic, is like this. I have a package installed called Fast Endpoints, which I helped steer the direction a little bit because I found it very interesting, and it's what I wanted to do with minimal APIs as well, and I was glad someone else was doing that, and I can just help with that. And then that's all I need to do to register my services, and then this is all I need to do to register my endpoints. And that's it. I'm not cheating, by the way. All I have in here is just some error response mapping to a validation contract, which again, I can just extract to a different class. But that's it. So I just want to recap. This is still technically using minimal API code. Now, you might think that this is too much, this is a lot, this is bloated. However, it is the path I chose, and it is the castle I decided to build. And that's my choice, which is what minimal APIs are all about. So, back to this. Let's talk about something that I call minimal value. And it's definitely not the Dunning-Kruger diagram with change labels. It's totally original. I made it. So, on the vertical axis, you have the viability of a project, of a specific type of project using minimal APIs. And then on the horizontal, you have the type of project, the way I imagine it when it comes to project lifetime. Because I think projects start in a certain way and they end up in a certain way if you have enough money. But you can also start at any point. It doesn't have to go through all the life cycle. So first, beginner projects. It makes so much sense to use minimal APIs for beginner projects. It's a no-brainer. You can just start with just 4 lines of code and you have something there. So we established that. Also demos. As you saw on the first demo, very easy to demo an API using minimal APIs, and also proof of concepts. It's great to have a piece of technology that you can just start building something with and then convert that if you want to something that can go to production and be very, very, very performant as well. Now, where I don't think they're going to have an international career necessarily is those chunky enterprise apps. Now, those are not limited to monoliths beyond saving. Modular monoliths can also be part of this. But I think that just because the type of company, the type of developer who works on those projects is a specific, again, type of developer, it doesn't make much sense to move from one thing to another, waste all of that knowledge that exists in each company and for that developer as well, for something that really isn't significant. Because yes, even if you did move to that other structure, you wouldn't really gain much if you took that risk. So I definitely don't see that being adopted there, and in my opinion, for good reason. Now, if you make a new app and you say, we're going to give that a go, then maybe try it, but I just can't see it happening. But where I do see that something amazing will happen is microservices. Now, microservices are small by nature, is in the name, microservices. So minimal APIs from microservices just make so much sense for me. And it also allows developers who work on microservices to choose their own destiny on the structure. I want to wrap this up with the importance of minimal APIs for .NET, because I think it goes beyond the code and beyond everything we talked about until now. I want to talk about how people get into a programming language in general. So first, they have an idea they want to build. They don't know what programming is. They're like, I'm just going to make a game. I'm going to remake Tetris. I don't know. How do I remake Tetris? Or in the programming language, what's the easiest programming language to remake Tetris? Then university, school, college, they just have it as part of the classes, and someone might be like, well, that programming thing sounds good, I'm going to give it a go. And you just depend on whatever the university or school decided for you to learn. Then curiosity as a beginner, this is how many people are starting. I want to get into programming. How do I program? How do I make a calculator? And it's all downhill from there, or hopefully uphill. Curiosity as an experienced programmer is another one. This is how I usually nowadays get into programming languages. Because of how many features are added in C#, I really want to see where they're getting inspired from. Spoiler alert, it's usually F#. But other languages as well, like Kotlin, Rust, are a heavy influence to the C# team. So I'm getting into those languages to have a more spherical view on how things are added into C#. And then last but not least, just because you get hired into the company that is using it, this is how I started with C#. I desperately needed for a job. I was doing Java beforehand. For some reason, my future would be building desktop applications in Java. Maybe not the smartest idea, but someone said, here's a job. So I took it. Thanks, Phil. You kind of changed my life. But this is in general how people get into programming languages. There are others as well, but I'm going to focus on these. You know, a parent is also another one, and so on, but we're going to leave that outside. So these three are the ones directly applicable to C#. Now, you could say, no, Nick, 3 and 1 is also applicable because of Unity, the game engine. And that is true, but Unity, the game engine, if you've seen C# from Unity, the game engine, you wouldn't really want to see that code, trust me. It's weird. It's a different thing. It's not the same thing. It kind of gets there, but it's not the developer you would necessarily hire, and it's not the developer that would want to work for APIs anyway. So let's leave it outside. So this is what we have. But this is the one that is actually really on our own destiny, on our own hands. We can choose the destiny. Because universities, schools, colleges, they can change which language they teach. And companies, they can change which language they use. So curiosity as an experienced programmer is actually the one thing left, again, outside of Unity, on how people can get into the language. And even Unity, if they decide to move away from C#, which I don't think will ever happen, but if they do, then we lose that as well. And that is bad. And the reason why this is bad is a train. So let's talk about trains. This one won't make so much sense as the Lego, I'm just warning you. So people get on board the train. People stay on the train, and people get off the train. And the train will keep making the journey as long as there are passengers. The moment there's no passengers, the train will just stop doing that because it doesn't make any sense for the journey to be made. So let's talk about the programming language Express. A, people pick up a language. B, people use a language and they keep using that language. and C, people stop using that language. Now, a language is dying when A plus B minus C is decreasing over time, which makes sense. The more people that ditch the language, or if the people ditching the language are more than the people picking up the language and using it, then we kind of have a problem. And there's a bit of a catch-22 when it comes to programming languages as well, because the more people use a language, the more people will use a language, and the less people that use a language, the more people will stop using a language, which is how, it's an interesting dynamic, but it is how it is. So C# is good at B and C, but A is a bit stale, people picking up the language, especially in the context of ASP.NET Core and APIs. And that is not C# to blame, because C# is a great language. People love using C# and they just stick with it for years upon years upon years. But we need to make it more accessible and make more people come in and say, hey, we're cool too. You can also have an API very quickly, or you can also have a system that you can deploy in the cloud very, very easily. C is inevitable as people retire. Like, it makes so much sense for .NET being 20 years old that you'd have some people doing it for so long that they can just retire and they don't need to work for it anymore. Minimal APIs are ultimately a step towards increasing A, to get more people picking up the language. So when I hear things like the .NET team should not be working on things like this is not for me. Why are they wasting my time? This is not what I asked for. This is not what I need. Well, if you want to be able to hire the next generation of C# and .NET developers, then it is for you, even if it's not for you. Thank you very much, and keep coding. Do we have time for questions? Sure, we have 9 minutes. So if I can't see anyone, so if you have any questions, ask me now. If not, we can just call it here and you can come over and ask me. Okay, let's do the second.